Welcome everyone to this webinar. I'm very happy to co-host this with David Nolet from Laurentide Controls. Today we're going to be discussing how to apply ISO 14224 for CMMS master data. Dave, can you move one slide, please? Thank you. So those of you who already attended our webinars, you must know me by now. I'm Johan. I'm the Director of Technologies for Spartakus. I'm an engineer. I'm the creator of Spartakus APM, and I've been in the reliability business for a few years now, and I've done a couple of projects, especially with Dave. We've worked together at Laurentide, and happy to have you on board, Dave. Can you give us a few words about yourself?
Yeah, sure. Thanks for having me. Hi everybody. Thanks for being here today. I'm a mechanical engineer. I've been with Laurentide Controls for going on close to 12 years now. And I've worked in reliability that whole time. A bunch of different things, including lubrication, oil analysis, maintenance strategies, a little bit of stores optimization, and also notably master data. So I've been involved in master data since 2019, and I'm not really so involved in the execution level anymore, but still with strategic project scoping, trying to understand our clients' needs, things like that.
Excellent. Thank you, Dave. Can you move on to the next slide, please?
That's right. Kind of forgot I'm driving there.
Yeah, no, it's fine. It's fine. You'll get there. So, a bit about Spartakus. Again, we are here to be a partner in engineering, help turn downtime into availability. So, of course, we have our software, Spartakus APM. Most of you must know about it. We do asset health, PM, digital rounds, lube rounds, etc. But also we offer a bunch of reliability services in all over North America, especially PM optimization, but also asset master data. And that's why we brought some experts on board, like Dave. Dave, you want to discuss Laurentide Controls?
Sure.
Very briefly.
So Laurentide Controls is what's called the Emerson Impact Partner, which means that North America is split up into a bunch of territories, and in our territory, we are the exclusive product and services provider for Emerson products. And that is kind of what led Laurentide to develop a rather large reliability team. So there were a couple of reliability products, like some of you may be familiar with things like the CSI 2140 vibration analyzer, which is an Emerson product. So that was kind of the one of the products that led Laurentide down the path of reliability. But we've grown our team to be quite large. We've got over 100 reliability specialists, I think is accurate at this point. And I listed here a number of services that we offer. So master data is at the top of the list because that's what we're here to talk about today, but we do reliability engineering. We do reliability audits, help our clients kind of see where they are and where maybe they need to improve in terms of reliability, which is really a high level, broad analysis. We help our clients implement predictive technologies like oil analysis, ultrasound, thermography, condition monitoring that goes with that, strategy development, like Johan mentioned a little while ago, lubrication, planning and scheduling, work management, and of course, training that really goes hand in hand with all of those subject matters as well. Yeah. So the company does more than that broadly, but I think that's really the relevant snapshot that I'll give you for today.
Yeah. Thank you, Dave, for this. So the agenda for today. So we're going to define master data. It's sometimes a definition that is not very, how would I say that? Not something that you know the definition by heart, or something that is very intuitive. So we're going to define what it means, what it relates to. We're going to talk about typically the problems that we see in industrial and manufacturing facilities with regards to asset master data. Of course, we'll talk about ISO 14224, which is a standard in the industry that we've been implementing for many years. And of course, we'll see the end results and the benefits, right? So as usual, don't hesitate to write down questions in the questions section of Teams. And also, if you want to intervene, it's not meant to be a monologue. So if you want to participate, intervene, ask questions, don't hesitate. We'll try to keep some time at the end for the questions. But yeah, so let's start with defining the what is master data. So we'll start with the poll. So we'll bring up the poll into the Teams window, and you'll have the ability to answer. What is asset master data? Is it the DNA of your assets? Maintenance starts here. Never heard of that in my life. Or you want to pass, right? So let's see the result. Once you submit, you'll see all the answers. For now, it really revolves around the DNA of your assets. Maintenance starts here. A couple of you guys never heard of that, and some of you seem to be hungry. Probably
that
you,
was
Dave.
me.
You skipped lunch, eh? And that's what happened. All right.
I put the burger up just for fun.
All right, very good. So yes, of course, DNA of your assets and maintenance starts here. So actually, I would have taken those two answers as good answers. It is definitely the DNA of your assets, and all of your maintenance activities start there. And this is what we're going to demonstrate during that webinar. So thank you for this. Let's move on, Dave.
It's a good definition. I like it.
Yeah, very good. So the definition, can you show all the animations, please? Thank you, Dave. So so what is a CMMS, computerized maintenance management system? We'll discuss that more on the next slide. But the master data is really at the core of a CMMS. So at the core of eMaint, SAP, Maximo, Oracle, Guide TI, whatever systems there are on the market, will each and every one of them rely on CMMS master data. So it doesn't matter if today you're using SAP or another type of CMMS. The definitions and the standards we're going to discuss today are common to all of these systems, right? So master data is really the foundation on which our maintenance and reliability programs are built and depend. Should we move on, Dave?
Yeah, maybe just like one little stipulation there is some of you might be looking at like SAP and thinking that's not a CMMS, it's a ERP, right? But it also functions as a CMMS. So some of the platforms that we're using as our CMMS might not be limited to that functionality, but also function that way.
Good point. Good point. Typically, what do you use CMMS for? Well, typically you want to increase your maintenance team's efficiency. So before CMMS, everything was done on paper or just verbally, right? And there was no work order management. There was no resource management, scheduling of work, no asset registry, no reporting and analytics, no parts management, et cetera, et cetera. So of course, the CMMS systems have brought a great deal of efficiency when they started to appear in the 80s or 90s, really, when we started to have computers embedded into industrial facilities, right? So a lot of gains and still a lot of improvements over time. The latest versions of major CMMSs like SAP, for example, include pretty cool features, right? A lot of good stuff, right? Today, what we're going to focus on is really about asset registry, what revolves around asset registry, and eventually what is asset master data. Can you move on, Dave? So what is the definition of master data? So really it encompasses a bunch of things. So asset hierarchy, the parts, and the bills of materials. So it's really what's going to be our focus today is what represents what you have in your facility on the field. So all of your machines. So built with the asset criticality. So the various areas, sub-areas, assets that you have will introduce the notion of functional location. Under these functional locations, what are the parts? What are the equipment? And also for each piece of equipment, what are the bills of materials that are needed to repair, maintain those assets? This asset master data, it is also the foundation to do a bunch of other things, right? It is your entry gate to criticality analysis. If you don't have a proper asset hierarchy, well, it's going to be highly difficult to do the criticality ranking analysis. If you don't have the proper asset hierarchy, it's going to be very difficult for you to build your maintenance strategy, all of your PMs, your loop program, etc. Right? And of course, the maintenance strategy is very well linked, sorry about that, to a criticality ranking. Without master data, you don't do work management. You don't plan, schedule jobs, because in the first place, it's going to be very difficult for you to identify and open up a work order if you don't have the right assets. Typically, one of the struggles we see is that someone will create a work order into a CMMS, and that person will not assign the work order to a specific functional location or asset. And that work order will be first very vague, repair, and it will be assigned to the building. Right, so repair something in the building. And so when the planner takes that work order, it's like, oh man, what am I going to do with that? Right, so a lot of inefficiencies. And of course, in the end, well, having the right parts, bills of materials built will greatly enable inventory management. All right, Dave.
All right, good intro. So now that we have a bit of an understanding of what we're here to talk about, we're going to talk about kind of the problems that our clients are usually experiencing. And what we'll see here is probably not going to be, it's probably not any of our clients that are experiencing all of these problems, but most of our clients are probably experiencing at least some of them here. So starting with the foundation, it's standards. Master data is a meticulous thing. You got to be very, very precise with it. If you don't have standards surrounding it, then you're going to have very inconsistent practices applied, and you're going to have kind of the flavor of the week, the flavor of the month. You even have sometimes the same person doing work different ways from one day to the next. So you'll have sometimes best practices. Maybe you'll by chance apply best practices, maybe because we don't have as good of an understanding as we'd like to have. We end up making decisions that then negatively affect how much we can get out of our CMMS. So not having standards is kind of the first pitfall that we come across from our clients. Another one that's pretty obvious is the asset hierarchies. I think Johan just kind of explained pretty well what happens when I don't have a complete, detailed, and accurate asset hierarchy. It's where do the work orders go? And I don't want to get too far ahead because I'm going to get repeating myself here, because we're going to see kind of the benefits of when we do apply the best practices, but you can kind of already see where it's going. Okay, we've got items or parts, materials, interchangeable terms for the same thing. We may have parts that aren't created in the CMMS. We might have parts that are poorly defined, and so I've got one assembly that has 4 different bearings on it, and they're just called bearing, 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 bearing. That makes it hard for my planners to identify which parts they need for a given job, right? I've got duplicate parts, which end up in duplicate inventory, which is money on the shelves. I've got unorderable parts. I made a part in there, but I didn't even put like the manufacturer's name, or vendor's name. So now, how do I even go about purchasing that part? That's kind of junk data. And if I'm doing any of that other stuff, I probably am not stocking at the optimal levels, which pretty obvious what that means. On the one hand, excess stock costs me money. There's just money tied up in that inventory. There's carrying costs associated with that. And on the other hand, if I don't have parts that I need to have, well, failures happen, and then I've got a real problem. I've got downtime. Finally, my bills of material, which are going to link those items to my asset hierarchy. If that link is not accurate, then I've got a whole lot of problems. So we're really looking at, efficiency, optimization of our operations. So why don't we have standards? Before we get into the effects, maybe we just weren't aware of kind of what the best practices were. We thought we were doing the right thing, but we just kind of went ahead and maybe made decisions that were suboptimal. Maybe we don't really understand the consequences that are going to come downstream. And there's always that, well, we've always done things this way, right? But just because we've done things this way doesn't mean that that's the best way to do it. So this causes us pain. Inconsistent data. If I've got different sites wrapped up in one system, that's going to be particularly problematic. I might not even be able to make that data mesh together. And then I might be looking at a big undertaking to try and make everything work together. So, a little repetitive there with the suboptimal. Okay, now asset hierarchy. Why are we having asset hierarchy that is inaccurate, incomplete, or lacking detail? Well, we've got asset hierarchies that were maybe incorrectly built from day one. And that could be structurally wrong. It could be information that's missing. We're not going to cover everything about master data here today. It's kind of a high-level view. So there's some clients are going to want more information in their hierarchy structure. Others might want less. So what incorrect means can mean different things to different people. Perhaps my plant is rather old. I've had design changes over the past 10, 20, 30 years, and no one's ever updated that in the system. And so therefore, I'm not matching my reality in my system. I got new systems that get added. I don't go into enough granularity. This is a pretty common one, okay? This is from an unnamed client here. This is a case packer. And we've always done it this way, was to create one asset for this. This thing had 1,000 parts. So you can imagine when work requests get put against this, it's hard to know, where am I actually working? What conveyor, what cylinder? There's so many different components and parts here. So you're better off kind of going into a little more detail to make something a little bit more understandable. So we made more assets, obviously, and we're trying to kind of find a happy medium. You don't want to go down to making every single bearing and cylinder into an asset, because that becomes completely unmanageable. But if you end up with not enough granularity, then you can't really see what's going on, and you have a lot of issues with planning, work management. Maybe less common, but we have come across this, building out your asset hierarchy from pre-build engineering documents, and then the actual build ends up being different. And so from day one, then we have kind of a break between reality and what's on paper. Or maybe we migrated CMMS, and that causes issues. I've never seen anyone who's migrated CMMS who didn't have issues, whether it's parts, a hierarchy, or something. There's always some data that doesn't come across or something that gets broken. So the pains are, I've already listed a lot of these when I was kind of explaining the previous slide, but it's difficult to identify work. Where do I actually have to go to work? It's difficult to plan. Huge bill of material. I have to try and describe to someone where they're actually going, let's say if they don't have enough granularity or if there's inaccurate systems. Work execution is likely to be slowed down because I'm back and forth trying to clarify things, trying to understand if I've got the right parts and I'm at the right place. And bad actor identification, well, my case packer is one equipment. Is that my bad actor? Because that's going to make for a difficult bad actor analysis if I'm trying to look at that level to see really what the problem is. And then from there, other more advanced reliability engineering metrics like mean time between failure, mean time to repair. What am I really looking at? So that's kind of the problem we see for hierarchy in a nutshell. If we look at parts, again, we said they're not all created in the CMMS or whatever the case may be. Well, why? Because migration issues again. Because maybe we ordered parts using a credit card. We didn't have time to make it in the CMMS. Maybe we only make parts when they need to be ordered. But then we're always kind of in a crunch to get them, right? But some people, that's the strategy they deploy is I'll build my bill of material as I order my parts. It's just when I'm trying to build a system, when I'm in a hurry to get something done, that rarely works well. Descriptions for our parts are not standardized in any way. They're not completed. Like I gave the example earlier of a single assembly with 4 bearings, and the sole description is bearing, 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 bearing. That's not going to be very functional for me. That's my planners aren't going to be very happy with that. This is kind of a funny one, a little bit into the details here, but creating with or without special characters, this is going to make duplicate parts. So, oh, this part had a dash in it, but I made it without the dash. And then the next time I looked for it, I put it with the dash. Like, it sounds really stupid, but this is why we need a rule set, because that's how we end up with huge excess duplicate inventory. Not doing an actual duplicate check, or, you know, I might have the same part that can come from different vendors, but could come from the same manufacturer. If I want to go even further, I can have multiple manufacturers making the same equivalent thing. Those are different things that I can try and attack that require maybe different level of effort depending on how far I want to push that. And some of our vendors are even creating new part numbers for the same part, which is infuriating. But if you're buying a new system, a new production line from the same company that you bought your previous production line, it would be a good idea for you to make sure that you aren't buying duplicate parts, because that is something that they do sometimes. Okay. I'm not analyzing my store's turnover. That's gonna make sure that I'm not having parts stocked at optimal levels. I just keep adding more to this list. I'm not identifying obsolete parts. If I do a look at my parts, my bills of material, I might have a whole bunch of parts in my store's inventory that don't actually go on anything anymore, or I don't know where they go, and I kind of just let that inventory sit generally. So that's going to require some kind of initiative to get that done. All right, so moving on to bill of material. That is going to be inaccurate, incomplete, because we never had time. We never had time to update it. We never had, say, documentation. So those are generally going to be the reasons that we don't have it. Again, CMMS migration can be an issue again. So the pain for parts and BOM is trying to plan work. I don't have the right parts on the bill of material. I don't have accurate bills of material. My work execution is going to be slowed down. If you put yourself in the shoes of a mechanic who comes across a broken piece of equipment, is asked to troubleshoot it, they are going to identify what parts need to go onto that equipment to repair it. If they've got a nice bill of material that's complete and accurate, it's a pretty easy process. They see what part they need, they can clearly identify it. It's either in stock or they can get it very quickly because we've optimized our store's inventory, and then we're back up and running quickly. But if I don't have that bill of material, then it's a matter of trying to figure out what parts go there, and do I have it in stock, and do I need to order it rush, and how is that going to affect my production? I probably have work delays, so maybe I actually planned to get a certain job done at the shutdown last week, but turns out I was supposed to have the part in stock and I didn't. And so now I'm actually going to have to delay doing that job. I had identified the need to replace a bearing, doing vibration analysis. Well, now I can't do that job right now because I don't actually have the bearing that I thought I had. So I couldn't do that intervention when I needed to, and now I don't make it to the next down day, and now I have a failure. I end up being in reactive mode, even though I was doing my vibration analysis to avoid being reactive. Because I mismanaged my parts and my bombs, I am in reactive anyway. Sometimes we'll even see people kind of find a makeshift part. There's a certain part that's supposed to go in place. I don't have it. What can I do? Can I find something else that has the same approximate dimension, something that will do for now? That might get me started today, but then, you know, I'm not going to be up and running likely as long as I should have been after that. So that's kind of a breakdown of what the problem is, why the problem is happening, and kind of the pain that we're experiencing. So we do have another poll here. And so we're going to ask you to enter, basically, if you had one thing that you could fix. And there is an other option on the screen, but I'm going to ask you to limit your others to master data related problems. But if you do have something that doesn't fit specifically in here, please feel free to enter that. So basically, we're asking you here, kind of what's your greatest pain? Did anything that we just talked about resonate with you in terms of what's actually having a negative effect on you? So hierarchy seems to be the most popular. We've got most people having answered at this point. And that's very understandable because it's kind of the foundation of the foundation, right? I mean, I'm not going to have a bill of material if I don't have that asset hierarchy. But we do see that we have parts, bill of material also being named here, and I'm not the best at math, but I think 2 people said other. So I don't know if anyone who said other would like to share what their specific pain is.
That was me, Dave, because I didn't want to, influence the results too bad.
Okay. All right. So was there anyone else who had something to share regarding other? So let's look at this standard. ISO 14224. This is a standard that was initially developed for the oil, gas, petrochemical industry. And if you read this standard, you'll find that it is very much geared for that industry. However, there's a lot of parallels that you can record, or there's a lot of parallels that you can draw to whatever industry you might be in. If any of you are just getting started in the world of reliability and maintenance, this can actually be something that could be a really good kickstart for your career, because this document is very involved. It's like 280 pages. Most of it is annexes, but there's actually quite a lot of information in it. It is oriented towards those industries, as I said, and those industries that are kind of pushing the edge of demand for reliability. So it kind of makes sense that those industries are the ones that this was made for. You can imagine in the petrochemical, oil and gas industries that if you're going to have unreliable equipment, then you're going to have environmental issues, probably safety issues as well. So they kind of pioneered this. So it accomplishes 2 things. First of all, it tells us what data needs to be recorded for use for reliability, maintenance, and regulatory purposes. And the other thing is it tells us the format in which we should be recording this data that's going to kind of standardize and make its usability enhanced. So that's like right in the abstract of the standard. Generally, you have to pay to access these standards, but I believe if you do some research, you may be able to stumble upon some older versions that I think are fairly accurate for free. So it does really establish a pretty solid framework for master data, but it goes beyond that. So it's going to tell us a whole bunch of different definitions. There's pages and pages of definitions of what is a failure, what is a failure mode, what is a failure cause, what is a component, what is a risk matrix, like everything is defined. What is mean time between failure? It defines the different types of failure modes that should be associated with every type of equipment class. So now you can kind of start to see why this document is pretty large. It defines what failure actually means, which when you think about it, could be interpreted a couple different ways. So there's an actual definition there. It does provide some example risk matrices that we could take and apply directly for our businesses. It gives us guides on how to do different calculations, different key performance indicators related to reliability. So there's really a lot of content that this standard defines. But ultimately, it is trying to facilitate our work and help us make better decisions. That data that we're collecting, the whole point of that data is to make our life easier and help us make good decisions, help us know where we need to focus our attention.
So you're definitely recommending the reading of ISO 14224 document, Dave?
I mean, maybe you're here so you don't have to read it. It's a bit long, I'm not going to lie, but it's not actually that hard to digest. It's long, but it's a lot of annexes, a lot of definitions. The actual meat of it, there's less than 20 pages that has a lot of content. But the goal here is really to just give you an idea of what it does, what it contains, and how you can leverage it. So basically, it is focused, and this graphic comes straight from that standard, right? So we have an operation of a system, of a plant, and in our operation, we will have maintenance events. We will have failures. And those events need to produce data. So what kind of data are we producing? What kind of data are we collecting? And then how are we using it? That's what we're really talking about. That is to facilitate analysis. And that analysis will then allow us to go back and make changes and potentially go back into redesign. And this is a continuous improvement loop, which is broken if we don't have data. So data is the key. That's why, I mean, we always say that master data is the foundation. If you don't have master data, you don't have asset criticality, you can't do a good maintenance optimization, and you're just never really going to get to being a top quartile or world-class performing plant. So as it relates specifically to what we're considering the master data, which is our asset hierarchy, our parts, and our bills of material, this standard defines the boundary of what is an equipment. Because you might wonder, does this belong to this equipment? Think of piping for a pump. You know, the pump might be inherently more obvious to some than others, but the piping, the valves that are upstream and downstream, this standard helps define that boundary. And I'll say here that while this standard is a very good guide, I do not believe that it is complete enough, detailed enough to be something that we can just easily read and apply. It's a good guide, but there's maybe a little bit of precision that we need to add, and we might not agree with it everywhere. Like for instance, here, I have a pump in the image that's shown here, and the standard indicates that my motor should be separate outside from the boundary of that pump's equipment unit. I'm not sure I would do it that way. So there's some interpretation that goes into it. There is a long list of different equipment classifications and characteristics in this standard. So this can be something useful if you want to see data that relates to all your pumps or all your agitators or all your tanks. By assigning a class to all of your assets, then you give yourself a way to group them and review data for them more easily. And it's even going to suggest to us what characteristics we should be recording for those equipment. So for my pump, it might be my impeller dimensions, it might be the flow rate, design flow rate capacity, things like that. So all of that is outlined for me in the standard. It's also going to suggest how we ought to structure our taxonomy or our asset structure or equipment structure. So they recommend what is shown in the pyramid in the bottom right here. And again, you might not find that this is the best fit for you. Like, is the top level really the industry? Or do I start at the installation, which might be my site level? That's going to depend perhaps on your needs, whether you have multiple sites in a single system, but the general structure does make sense. It differentiates what is a location versus what is an equipment. And could get into a little bit of detail here. I'm going to just try and keep it light because I am kind of conscious that we don't have that much time. But a location is an address, and an equipment is a tangible physical piece of equipment. So I'm going to want to create an equipment where I want to track something. Think of something like a pressure safety valve, which is regulated, which I'm going to need to be able to prove that I maintained or rebuilt or had it recertified or whatever the case may be. I need to have records that link specifically to that given pressure safety valve, which has a serial number. But that pressure safety valve lives in a space. So that is what a location is. That would be more like a functional, could be spatial, but recommended usually functional space. So my process water pump 1 is a function, is an address, and there is physically a motor and a pump that get installed there. And if I want to track those individual motors and pumps, then I'm going to have to record a serial number and create an equipment record to track those. So there's a differentiation there. I hope that's not too fast, but it is a relatively important concept for understanding the asset side of master data. This standard is not specific to your CMMS. So depending on what CMMS you're using, you may apply it different ways. You may have limitations to your system that don't allow you to do everything that you would want. Some don't allow you to differentiate between location and equipment records. So what are you going to do about that? So it's a good guideline, like I said, but I'm going to have to still do some thinking for myself. It's going to be hard to take this standard and really end up with something that's going to work with 100% clarity for me. Okay, so we do have the third and final poll here. So the idea is now we've talked about kind of what our master data looks like, what the problems are, what it should look like. Curious to know your input. How is the quality of your data? I'm hoping that this is going to have shed a little bit of light to you on kind of where you are and maybe what you're missing out on with the quality of data that you have. So we have most people voting 3 out of 5, which means you have a workable system, but definitely some imperfections, definitely a lot of room for improvement. 52% at 3.1. Okay. So what are we hoping to achieve in, say, doing a master data optimization project? We are hoping to go from this suboptimal hierarchy that we described to a detailed, accurate, complete hierarchy. We are looking to solve all those problems that we just described about parts. So now they're all in the CMMS. I can differentiate them clearly. They have a unique identification, a unique description as much as possible. I can order anything that's in there, and I am stocking them at the right level, which is kind of its own thing, but does overlap with master data. And finally, my bills of material, I can trust them. They're complete. So what this might look like, well, here's what an asset structure, sorry for the low resolution image, but here's what an asset structure might look like in that asset tree structure. And here's what that same structure might look like in a CMMS, like in the given case, which is SAP. So I should be able to navigate, I should be able to drill down. Also, here's an example of, kind of some suboptimal part versus an optimized part. I've got a spherical roller bearing, and the description that I got from the OEM was just spherical roller bearing with a part number. Well, If we do a standardized description, it's always going to be a class, a subclass. So in this case, bearing, spherical. And then I'm going to list attributes in order of importance. I might go and do online research to find this additional information. I'm not just inventing it out of thin air, right? But I would like to have more complete, better quality descriptions. And so I use my part number to go and get my description wherever I can. So what I've achieved is I've got best practices identified, documented. They are my reference. That's my standards. My standards are my controls for sustainability and time. I'm making work identification easier. I'm making planning easier. I'm making my execution of work, both planned and unplanned, faster because it's clear. There's fewer mistakes. I've got the proper parts identified, all of that. The parts I needed were in stock, and so I don't have those work delays that we talked about earlier. I don't have as much downtime for multiple reasons. I've got faster work execution, but also that corrective work does get done instead of the corrective work that didn't get done, and we ended up reactive, excuse me. We're using the right parts, not just the parts that fit. And then we are doing bad actor identification. We are doing reliability engineering. We are getting valuable metrics out of our system. So that's kind of how would I say, from a high level view, what my benefits are going to be. But if I want to look a little bit more concretely, I'm going to have reduced unplanned downtime. I'm going to have reduced planned downtime as well. Everything is easier to work from. There's going to be fewer mistakes. Work execution is easier. I'm going to have less duplicated, obsolete, erroneous inventory. That's money in my pocket. Every part that I eliminate from my stores that's obsolete, let's say, I'm eliminating carrying costs that are associated. I'm enabling my continuous improvement loop that we said without that data breaks that cycle and doesn't allow me to make any of those improvements. And something that we haven't really mentioned yet is all this saved time is kind of upgraded. All this saved time that my mechanics, my electricians are getting their work done faster can be repurposed for other value-added tasks. So maybe they can go and do preventive or predictive maintenance activities that are going to help also boost my reliability. So it's kind of like a continuous improvement, vicious cycle. We're using correct parts, and we've got a safer plant. We've got a safer plant because we've got a more reliable plant. And where we have a more reliable plant, we're safer. We're going to be working less in reactive emergencies where we're trying to cut corners. We're trying to go fast, so we're tempted maybe to cut corners. Maybe we're tired. So we're going to have a safer plant where we're more reliable. From a more quantifiable level, and these are numbers that I'm very comfortable with because they're rather quite conservative. We expect that if you go through this exercise of optimizing your master data, and this of course depends a little bit on where we start from, but I think bringing it from that 3 that we saw a minute ago to the 5, you're going to bring down your unplanned downtime by 20%. And you're going to bring down your planned downtime as well. Maybe not as much, but work execution gets done faster. Everything is clearer, fewer mistakes in the planning. Everything gets done more quickly. Doing an in-depth duplicate check, and this is something that's going to be particularly true for like a greenfield project, which is what we're going to see in a couple more clicks here, but doing a careful duplicate check of all the parts that I'm potentially going to buy to make sure that I'm not buying the same parts twice is probably going to save me anywhere between 1/4 and 0.5% of my replacement asset value. So that doesn't sound like a big number, but your replacement asset value for your plant might be $200 million, $400 million. So 1% of 400 million would be 4 million, 0.5% would be 2 million saved in not buying duplicate inventory and then not having those carrying costs associated. So the number I usually throw out to our clients when we are kind of having initial talks without coming up with a concrete number of the value added is I expect that every dollar invested in master data will bring $3 of value recurring every year because of this reduced downtime, because of reduced carrying costs, reduced inventory. So like I just mentioned, a greenfield project, it's very easy to buy duplicate inventory. And we have seen it where just our deduplication process, which is generally a little bit more pushed and in-depth than our clients do on their own, can generally roughly approximately pay for the project. So you're looking at a return on investment that can be paid for before your plant even starts up. So that brings us to the end of the presentation for today. I hope you found it interesting. Maybe a few subjects that kind of get repeated a little bit there, but I think we did cover the basis there that if you don't have good master data, we saw all the pains that is causing you. And also, I think all the benefits that you can achieve by going towards the best practices.
Yeah, very good, Dave. Excellent. Just a couple of precisions there. When you mention carrying costs, not sure everyone is familiar with this. Can you give us a definition about what carrying costs?
Yeah. So
what
really,
it entails?
When you buy a part, it's the beginning of your expenses. So you've got to store it. And so there is depreciation of the value of that part. If you went to sell that part back a year later, you'd be able to get most of that value of that part back. But the longer it sits on your shelf, it is depreciating. There's also taxes. You are taxed on all of the parts that you have in your inventory. So the larger your inventory is, the more taxes you're paying every year. You're actually out of pocket that money. There's capital costs. So that's money you don't have. If you have an extra $1 million of stores versus what you need, that's $1 million that you don't have to invest elsewhere in your plant. There's insurance. There's labor for the management of your stores room. There's the utilities to keep the lights on in the stores room. There's shrinkage, which is things disappearing over time for one reason or another. And the average numbers you'll see if you look online of what that is going to be generally between 20 and 30% of the cost of a part per year. So if you want to take a round number and say 25%, well, if you've got $1 million extra worth of inventory on your shelves, not only could you probably sell it back and get some money, it's costing you 250 grand every year to keep it there.
Yeah. Excellent. Thank you. Thank you for this, Dave. And another thing I want to emphasize on was the benefits of having proper parts in inventory with regards to proper planning and scheduling. You cannot expect to have a world-class maintenance planner doing a proper job if you don't have the proper parts in store, right? So reserving parts, doing kitting, don't even think about it if your parts catalog is not properly codified and you don't have the right bills of materials. And one last question I had for you, actually, Dave, was typically when an asset hierarchy is built, how many sub-levels typically you see in maximum? Because I've seen a lot of, I've been to a lot of places where you can either have 1 or 2 sub-levels, or you can get up to 10 or 15 sub-levels. Is there a middle ground? Is there a sweet spot from what you've seen?
I would say there's a middle ground. Again, it depends how high you start, right? Because like what ISO 14224 says, you're starting with the industry. But that would be a company that has multiple industries that they want to represent in a single system. If you have a single plant for your whole company, then you're starting already a few levels lower, right? And a lot of our clients are starting there because even if there are multiple plants, their CMMS might be independent of other CMMSs. So in that case, I've seen like as little as 5 levels. Most of the time, our clients will be satisfied around the 7 to 9 range. So that's probably kind of the sweet spot. And especially, like I said towards the beginning, there is you want to find that happy medium, because you can get to a point where you kind of just know enough to be dangerous there. And you might think, without having to live with the system, that if you can get more granularity, more precision, that's going to be better. But it becomes actually kind of infuriating for people who are trying to know where to put a work order, right? So one of the to also answer your question this way is, it also depends a little bit on your CMMS's capacity to have part assemblies, because if, like, there are some CMMSs that they can only have 2 levels of part assemblies. And if you can only have 2 levels of part assemblies, well, that kind of dictates how many levels of hierarchy you need. Because what you want is you want to be able to easily find the parts. So that means small bombs, and that might be in sub-assemblies of parts, and sub-assemblies again, possibly. But what you want with work orders is you want enough granularity that you know where to go, and you know what you're working on, but not so little, or not so much granularity that everything is way too precise and you have to select almost a part on which to work, and then work orders end up getting put in the wrong place anyway, right? So what we're trying to do is make sure that we're grouping work orders together as they should be, so that when I am trying to do reliability engineering and find my bad actors and see what cost me money last year, what broke down a lot last time, it's not too dispersed, right? It needs to be reasonably concentrated so that I can identify, but also precise enough so that I know what I'm doing. Because if I put all the work orders at the plant level, it's just chaos.
Yeah, of course. Thank you for this. Can I ask one last question? You mentioned earlier in one of your slides the example of a case packer. So for those of you who've never seen a case packer, it's pretty huge type of machine. Of course, depending on the type of things you want to put into those cases. But in that case, it's pretty big. At the end, Dave, with how many functional locations or sub-assemblies did you end up with instead of just one case packer? Was it like 10, 100? Remember?
It probably should have ended up around in the 20 to 30 range. That probably would have been optimal. And so it's a little bit of a lessons learned for us. We went beyond that. And that is feedback that we got, that it was a little too broken up, and that made it actually harder to work with. But we did have the constraint. So I'm kind of speaking from a real example earlier there. We did have the constraint that they only had 2 levels of part assemblies.
Oh, yeah.
And so you kind of have to gauge what your priorities are. Do you want to you break that case packer down to 100 assets? There were 1,000 parts. That's 10 parts per bill of material. That's real easy to navigate. But is that too many places to put a work order? Maybe the right level would have been around 25 or so. Yeah. And I mean, different people have different opinions too. There's not necessarily one right answer. So you kind of have to understand the realities of the people you're working with, what they're used to doing. When you want to make an optimization, you kind of have to be aware of the culture change that you're requiring and the pushback you might get back on that. So you need to kind of try and, I guess that's kind of where the experience of having done a number of projects like this pays off, versus trying to do this on your own first time and getting it right.
Of course. Well, thank you, Dave. I've asked a couple of questions. Do we have questions in the audience? No?
Yeah, I do. What are the main things to consider when starting an optimization project on master data?
What are they?
Yeah, the main things to consider, what you have to keep in mind when you start doing that.
I'd say the biggest thing is your data. Like, where are you getting information from? Because we can't just make things up, right? And so the kind of easiest way to do a master data project is on a new system, a new line, or a new plant, because you've got all the documentation and it's been delivered to you recently. Whereas when we go to plants that have been running for 50 years, the documentation is lost on paper. There was a fire, out of date. We replaced half the equipment. We don't have the documentation. And it's not that we can't do a master data project in that case. It's that if you don't have the documentation, and ideally in digital format makes it a lot easier to work with, then you're kind of stuck with doing field validation, field master data, which can definitely be worthwhile, but is very labor intensive. Now you're talking about walking down the line. Maybe you take P&IDs and you're validating whether it's matching your P&IDs or whatever the case may be, but you're walking down the line. You're trying to build an asset hierarchy based on what is physically installed. It's easier to miss things. You might end up with more of a spatial structure than a functional structure, which can work, but has certain disadvantages. And so generally, when our clients don't have documentation and we explain to them, this is what it looks like, there's nowhere else to get the information. You have to go in and actually walk it down and try to identify parts that are visible, and maybe look at work order history as well, or purchase order history is a little bit tougher, but that can work as well. And piece together as much information as you can. So when you're doing that field type validation, it's labor intensive, and it's not going to get you all the information because there's a lot of parts that are not visible, that we cannot see, that we do not know what is inside a lot of different equipment. But I usually tend to say to our clients that type of exercise is worth doing for our critical assets. If I've got my top critical assets that don't have bills of material, it's worth it to make that investment to get as much information as I can to try and build bills of material as complete as I can for those critical assets. Now you finish that exercise and then you can decide whether you want to do it for the moderately critical assets and probably never for the least critical assets, but it's probably worth doing at least for your critical. But really, to answer your question in short, documentation. Documentation is the key. The quality of the data that you have dictates the quality of the outcome.
Awesome. Thanks.
Thank you.
Any other questions?
Yeah, I have a question. It may not be a question, but a contribution. Usually, the CMMS platform comes in the enterprise after the accounting platform regularly. And in the accounting platforms, there are some data that has been mastered. And when you are mastering the technical data, I think that it is very suitable to take into account this existing master data in case to to be able to communicate between these different platforms inside the company. So in my work experience, I used to take into account this accounting data master in mastering the technical assets. This is what I want to say.
Yeah, so if I'm understanding correctly, I mean, SAP is an example, right? Where it's fine. It's an accounting software first and foremost that we've integrated to make it our maintenance management system as well. And yes, and that's like I was saying in the beginning, there's master data can go a little bit further than what we said, but we can absolutely link it with different costing centers and linked to our accounting in different ways as well, if that's what we want to get out of our system. So that is kind of one of the key things as well. To go back to the gentleman earlier's question is, what do we need to get started? Well, our standards will define what we want out of our system. And so what we want in terms of interaction or, data from an accounting standpoint, that can all be integrated into the decisions that we make too. So I don't know if that relates well to your comment or perhaps not.
Thank you.
Okay, thank you for listening.
Thank you.
And
All right. Well, thanks a lot for your time, everyone. As usual, it was recorded, so it's going to be broadcasted on our YouTube channel. And if you want to go back to it, share it with some friends or colleagues who could be interested, well, don't hesitate. And you'll have a good day. Work safe, and we'll see you in a few weeks for our next webinar. Thanks, everyone.
everybody.
Thanks,
Have
Dave.
a nice day.
Bye-bye.